In this video, we're going to quickly go over 3 different vocab words that we can use to analyze a phase change diagram. The first word that we're going to go over is the word entropy. You can see this word entropy on the screen right here. So entropy is all about organization. The more organized something is, like these blocks on the side, the lower the entropy. The less organized, the higher the entropy. Entropy likes disorder. So if we say that something has a high entropy, we're saying that it is very disordered, just like these particles here. If we think about how this applies to phase change, on the screen I have a solid, I have a liquid, and I have a gas. As I move from solid to liquid to gas, I'm getting more disordered, which means that I'm increasing my entropy. Here's a look of it on the phase change diagram. On our curve here, you can see that low entropy is down at solid, while high entropy is up here at gas. Pause the video for a moment to copy down this image with the entropy labeled. Low entropy at the solid, high entropy at the gas. The next words that we're going to talk about are exothermic and endothermic. You might remember these from last year. Pause the video for a moment to take down the definitions. Exothermic is heat energy being released. That means that the heat is exiting, like exothermic, exiting the container. On the other hand, endothermic means that heat energy is being absorbed. Endothermic goes with heat entering. We can look at these on a phase change diagram as well. As you move up the curve, you are putting heat energy into your substance. If I'm going to go from a solid to a gas, I have to put in heat energy. That means that the process going up the curve is endothermic. When I go down the curve, it's going to be exothermic. The heat is leaving my substance as I go from gas to liquid to solid. Take a moment to copy this into your interactive notebook. The last vocab word we're going to talk about is enthalpy. We've talked about enthalpy a little bit before, but enthalpy basically means the general heat of the solution. So if I have heat going in, my enthalpy is getting bigger. If I have heat coming out, my enthalpy is getting smaller. So this moves in a very similar way on the phase change diagram. If I go up my curve, I'm adding heat, which means my enthalpy is increasing. If I'm going down, my enthalpy is decreasing because I'm taking out heat energy. So here's a quick summary. Make sure that you have all these notes from this page in your interactive notebook. If I'm moving down the curve, that means that my entropy is decreasing and my enthalpy, and it means that it's exothermic. If I'm moving up the curve, it means that I'm increasing my entropy. My enthalpy is also increasing, and this is an endothermic reaction. For example, if I said that I had solid ice going to liquid water, I could claim that I increased my entropy, that my enthalpy went up, and that this was an endothermic reaction. Whenever you see questions like this, you should sketch out your curve, and you should think about which way you're moving on the curve in order to answer the question about entropy, enthalpy, or exo or endothermic.